we can call because like grouping X. So the
grouping that already do as like a lot of people can't take out any factors, you can't do any of the
we have yeah, like this. Yeah.
So what if you take an article and have to do all grouping, we don't call that grouping. We only call it grouping if you are taking some of the terms together and some of the terms together, not all of the terms. But yes, you are on the terms of grouping would be to get one term.
No. Next one.
All right, guys, are there any questions on those first two? Please take note, guys, and it could happen that you are getting something like this, where you might, show this. Getting something like this in G, where you might be a little bit tempted for the score, it would be so nice if you could just cancel out those two x's, right? But then you would lose marks, please. You're not allowed to do that 2 terms over 1 term, so you cannot cancel out. Remember yesterday I said, if you feel like it will stop you from canceling stuff that you aren't allowed to cancel, leave the brackets around the 2x minus 1 there. Then you can see very clearly that you can't cancel out, right? Yes? 1 over 2x. That is fine, but again, you won't get an extra mark for doing that. So it's almost like extra time that you spend. Okay, but you can do that if you want. All right, there we have k. The answer was x plus 1 over x. Again, we cannot cancel those 2 x's because we have 2 terms at the top. Then L was a very nice one. It ended up with an answer of 1. Guys, please remember when you are cancelling everything out, it's not 0. Remember when you're cancelling out, you are dividing. So anything divided by itself is just 1. So the answer there would be 1. I didn't actually show all my cancelling out here. I can do that quickly. So here, the x plus 1 and x plus 1. In this first line, you're taking out x plus 3 as a common bracket, right? Left with x squared minus 2x plus 1. Then after that, you can actually cancel out the x plus 3. So you are left with this trinomial, which I'm hoping you guys were able to factorize, right? X squared minus 2x plus 1. You would say that I'm looking for factors of 1, and the sum of those factors must be negative 2. So we have to be negative 1 and, negative 1 and negative 1. So I just wrote it as x minus 1 squared. But you could have done x minus 1, x minus 1. Right? It will be the same thing. And then there we go. Everything divided by itself is just 1.
I'm just noticing now, like, every different parts,
Well, then that's fine. As long as you didn't do something that you weren't allowed to do. What did you do?
When I look at I just need squaring of the x minus 1 bracket, and then I don't say primarily about what then I can put it out that way.
Oh, so you have to multiply it out. Yeah, that's right. Yay. Any other questions, guys? Can we move on? All right, 1.22 was a bit more complicated because we were multiplying and dividing. So we had to do more factorizing and we had to try and cross cancel. So did anyone else get this answer for 3x? Okay, good. If you didn't, just try and find your mistake. But guys, like I said yesterday, these questions count a lot of marks. Often you'll get a mark for every single factorizing that you do. Maybe for this last fraction, you might just get 1 mark for both of these factorizings because they're very similar. Okay, so that might be 1 mark there. 1, 2, 3, 4, and then 5 for the final answer.
For the final answers, you pick like that always and never I'll multiply
You
out.
never have to multiply it out, but you can if you want.
Okay, thank you. Yeah, the previous is next time. We had to multiply.
Yeah, it is a bit of a tough up. It's not really, it's almost like you can ask yourself, what is simpler, having just a bracket squared or split it? It doesn't really matter. Or like you put it in. Not very possible. Okay, for G, you have to do it different times for that middle fraction. So you can just check there. So that I did the different times and the factorizing in one step. So I also this first trinomial we couldn't factorize, right? You guys notice that? Couldn't find factors of 4 that when you add them together will give you 2. Right? Because the factors of 4 are 4 and 1, and if you add those together you get 5, and then 2 and 2, and if you add those together you get 4. You can't possibly add the factors of 4 to get positive 2 as an answer. Okay, so this is a trinomial that you couldn't factorize. Here at the bottom, this is the difference of 2 squares. Okay, then I changed the division symbol to a multiplication. This now went to the top. So if we're looking at this, we can take out x as a common factor. I would make this xy plus 1. And then this x cubed minus 8 went to the bottom, right? And this is the difference of 2 cubes. Okay, do we remember how to do that? The square root of x cubed is x. Sorry, not square root. The cube root of x cubed is x. And the cube root of negative 8 is negative 2. So that goes into your binomial. Then you use your binomial to set up your trinomial. So you take x and you square it. The first term squared. For your middle term, you multiply these two together and you change the sign. Right? So x times negative 2 is negative 2x. Then you make that positive 2x. And then you square the last term, which will give you plus 4. And guys, do you see that it actually worked out quite nicely? Because we got the same trinomial here at the bottom. All right. So even though we couldn't factorize that one, which is maybe a bit disconcerting at the beginning, we got the same unfactorizable trinomial at the bottom that we could then cancel off. All right. Then here I took out y as a common factor, x, y. Obviously, I just left as it was. Cancel out everything that I could, and I was left with 1 over x minus 2. Right? If you're canceling out everything at the top, you can't just leave the numerator blank. You can't put a 0 in the numerator. It's actually a 1. Okay, because we are dividing. Then in G, I actually think there was maybe a mistake in the question because the answer didn't match up with the answer at the back of the book. Did anyone get this as well? Okay, let's just check that I got it down correctly. I've checked multiple times, but there might be a printing error in my textbook. Yes.
What I just want with x squared. Oh no, I don't think wrong there. Yeah.
Yeah, guys, remember this is an x squared plus 4. We can't factorize this one, right? X squared from the left of the squared. So yeah. Remember 4x squared minus 2x squared is just 2x squared. Hey, we like that. No, I didn't. Is it? Was it a 4x? Okay. So see in my book, I thought there was maybe an issue with this one. Because in my book, you see there it does say 4x squared minus 2x squared. Okay, so just check guys. If it does say that in your textbooks, can we actually change it? So that doesn't happen in following years again. So are you saying this is supposed to be a 4x? Yeah. Minus 2x squared. Is everything else the same? I'll fix it now. It just, you just did this one, so it's very nice. 4x minus 2x squared. Okay. That's fine, guys. I'm going to fix it quickly. All right, so then let me just check here. 2 minus x. And then I would have to do a switch around. Just check the other fractions also, guys. Please just make sure that those are the same from the other books. My book is obviously an earlier edition or something. Before they're not the same. They are. Okay, thank you. All right, guys, so let's just quickly go through all of that. So x squared minus 4x plus 2x minus 2, right? Over x. Fine. Then this division symbol needs to turn into a pi. That x will go to the top. We have 2x squared plus 8, so you take a 2 out, all right? And you're left with x squared plus 4. this again turns into a times, that x will go to the top. And now from here, do we notice that we have 2x as a common factor, right? So you would take out 2x from both of these terms. So 4x divided by 2x is just 2 minus 2x squared divided by 2x is just 8. Please? Yes, you could have done that. Yeah, I'm going to do that now. So guys, you could have taken out negative 2x right from the start if you noticed that this was going to happen. But do we see that we have an x minus 2 over here and a 2 minus x over here? So we have to do a switch around, right? Which is what we do basically if you are taking out negative 2x. So let's just see, was there anything that I could cancel out already? X plus 2, not, this I can't cancel out yet. Basically just, sorry, let me actually just take away all of these pink markings as well. X and X and X. So I can basically just cancel out one of these x's at the top with that x there. You don't have to cancel out right at the start already at the beginning. Oh, sorry, there's another x that I can cancel. Yes, sorry, I didn't see that. There we go. Okay. Are we fine so far? Okay, now here we're left with, and I'm actually just going to rewrite the whole thing. You could kind of do it in your head if you wanted to, but I'm left with that over 1 times 1 over 2 times x squared plus 4, right? Times, now this I need to now change to a negative 2 so that I can change that bracket to an x minus 2. Okay, and I need to cancel out that x. Okay, so I'm actually glad that this came up in this question, that we need to remember that if we have an x minus 2 and a 2 minus 8, we can't cancel them out. We need to change one of them by doing a switch around. Okay, remember when we're doing a switch around, we change the sign in front of the bracket. In this case, in front of the 2 that's attached to that bracket. So that positive 2 needs to become a negative 2. And then we change the signs inside the bracket as well. Okay, then we could actually cancel out the x minus 2 and x minus 2. Not a wonderful answer, but it is better than what I got originally. So what is left at the top then? X plus 2, hey, and at the bottom, negative 4, bracket x squared plus 4. All right. Oh, you mean you multiplied it out? The bracket. You could have done it here. Yeah, okay, so I'll just show you quickly. At the top, x plus 2. At the bottom, you can leave it like that with your negative 4 and then your bracket x squared plus 4. That's what I was saying. Sorry. Or you could have multiplied it in. Or guys, you could have just put this minus and that. Okay, because it's a positive term if you want to put brackets around it over a negative. Okay, but it's up to you. You can also just leave it like this, guys. That's fine. You'll get 2 marks for that. Just fill my lines in quickly. Okay, so not a beautiful answer, but a simplified answer at least. All right, any questions, guys? So what I want you also to notice is that if you are getting an answer like this that doesn't look great, it doesn't look like it's not a 1, you know, it's not like a 1 over an x. It is possible, okay? In most cases, when we are taking paper exams, we do try to take questions where most of the things cancel out, but it doesn't always happen. Please? So are you asking how I'm multiplied in? Yes, I say that. Yes, you can do that. I said you could. Negative 4x squared minus 16, and then you take out x plus 2. But you present it's a negative 4x squared. The number or the term in front has to be positive. You see a difference of 2 squares. It can't be a negative and a negative. You see, so if it was just 4x squared minus 16, yes. But because it's negative 4x squared minus 16, does that make sense? Can we just write this here? So this, you have negative 4x squared minus 16. That's not a difference of 2 squared because of that minus. What do you mean take out? So you're saying taking out x plus 2 at the bottom, basically, to cancel it out. Take out an x plus 2 at the bottom. So if you take out a 2, okay, you can just take, if you take out a 2 here, you're going to be left. No, but you can't do that. No, I hear what you're saying, but I'm saying you can't do that. No, so if you want.
That's a minus the bishop and your x squared.
So the thing is, you can't take out multiple terms. You can only take out one term or one thing as a common factor. So here, so we will explain why you can't. It's just x plus 2 is not something that you can take out. I don't even know how to explain it. It's not, there's no x plus 2 in this expression. Yeah.
And then you would end up with an x plus 2.
Yeah.
That we have together. You would not ever be able to make it x plus 2 and something else.
Yeah, so look at this tricky move. This was an x squared minus 4. Right, then we put it down. You see, because then you could have taken out an x plus 2. Then you could have split this up. If this was x squared minus 4, you could have split it up into x plus 2, x minus. But because there's a plus there, you can't do that. Yeah. No, you don't have to put it in brackets. When it is written in the numerator, the brackets are kind of implied. You can if you want, you don't have to. Okay, we need to move on to addition and subtraction of algebraic fractions, which is the more difficult section. But guys, for tomorrow's test, I'm going to show you, these are like grade 9, level 1. You only need to be able to do the grade 9, level 1, where you can have algebraic terms in the denominator, but it's always only one term in the denominator. I'll show you now the difference between a grade 9, level 1, and a grade 10, level 1. Okay, you only need to be able to do the grade 9, level 1 for tomorrow. Another thing on tomorrow's test, you need to be able to do grade 9 level equations as well. All right, which is not in this section. So that class is supposed to be, I think, yeah, the lines are blurred a little bit. It was originally supposed to just be a revision class, so grade 9 algebra revision. But they've put in the grade 10 factorizing and the grade 10 products, if that makes sense. So all of those new product shortcuts, you need to be able to do those. We did summarize them all in your book. All right. And then all of the new factorizing that we've done. So like the more difficult trinomials, the sum and difference of 2 cubes, and then also grouping. You need to be able to do that for tomorrow. But as far as the fractions are concerned, right, these algebraic fractions, you only need to be able to do the grade 9 level 1, and the same goes for the equation. Right, I will write a little notice on Google Classroom a bit later, just what I said now. I'll just cut that up for you. So if you are feeling unsure, you can just go take a look at that. Yeah, I'll do that at the end of the week. Okay, just copy that down, and then we are going to do this example. So let me just draw in my lines. Yes. Okay, now guys, next to this heading, I want you to just write whenever we are adding or subtracting algebraic fractions, we need to be able to find the LCD. Right, the lowest common denominator. Guys, the LCD is basically the lowest common multiple of the denominator. Not sure if you know that, right? So we can just make a little arrow there. LCD is actually the LCM of all the denominators. And what is an LCM? The lowest common multiple. It's something that all of the denominators in this case can divide into, right? Without there being a remainder. So if we had a 2 and a 3, for example, the LCD, the lowest common multiple of 2 and 3 is 6. All right? Now we're looking at 3 denominators here. We need to find the lowest common multiple of these 3. So we need to find the smallest expression. I mean, when I say smallest, I mean, yeah, we can't just actually multiply all 3 of them together. Some people think that you have to do that. Some people think you just multiply all your denominators together and that's your LCD. Okay, that's not actually what we need to try and do here. We need to find the lowest expression that all 3 of these can divide into. And guys, when it's numbers, I think you guys are fine with that. Okay, it's quite easy to find the lowest common multiple of numbers. But when we are introducing variables, it gets a bit more complicated. So what we need to do is we need to check which variables do I have in these 3 denominators. So we see that we have an A and a B, right? So the LCD has to include A and B. Now we check what is the highest exponent of A that we have? A squared, right? 2, that's the highest exponent. So in order for this first denominator to divide into the LCD has to have an A squared. Okay, if the LCD doesn't have an A squared, if it just has an A, for example, then we can't divide this into that LCD. Okay, so I'm just going to write here the lowest or smallest expression that all denominators can divide into. Let's just put it in forward. So that this is fine after that. So guys, if they had been numbers in those denominators, you would find the LCD, the LCM of those numbers like you always do, right? So say there was a 2 there and a 3, then 6 would have to be in your LCD. Now we have an A squared. What is the highest exponent of B that we have? Just 1. So we need to have a B to the power of 1 in the LCD. And that's it, guys. The LCD is going to be A squared B. All right, let's write that on the side. LCD is A squared B. Because if the LCD is A squared B, all 3 of my current denominators can divide into that. All right, we don't have to put an A cubed because there are, or an A to the 4 because there are 4 A's. All right, we don't need to do that. We just look at the variables, we take them to their highest exponent, that goes into the LCD, and we need to make sure that we are including all of the variables. Okay. Now guys, hopefully you can remember this. We now need to check each of the fractions. We need to write them over that LCD. All right. For the first fraction, it is already written over a squared b, so we don't need to do any multiplication here. For the second fraction, the denominator is ab. I need it to be a squared b. So what does that multiply ab by to get a squared b? A. So you multiply the bottom by a, but then that means that you need to multiply the top by a as well. For the next one, the denominator currently is a. I need it to be a squared b. What does I multiply a by to get a squared b? ab. You do the same at the top. Okay, the last term is not a fraction. All right, but we need to turn it into a fraction. So 5, that's the same as 5 over 1, right? So the denominator currently is 1. I need it to be a squared b. So I have to multiply it by a squared b. Then I must do the same thing at the top. Now we're going to do that multiplication. And if it's okay with you guys, I'm just going to put it as one fraction right from the start. Okay. Do we see that once I do the multiplication, all of my denominators are going to be a squared b, right? So then you can just write it over one fraction. If you want to, you can still do your 4 separate ones and then put them together on one denominator, but I'm going to do that from the start. Okay, so my first fraction, that numerator is going to stay 2. For the next one, there's a minus in between, right? So I need to put a minus in front of this numerator. 3 times a is 3a. There's a plus, so the next term is going to be plus 4ab. And then plus 5a squared b. And that is then all over the same denominator, which is a squared b. Yes, in this case it is, because I actually can't simplify any of those terms at the top. Right? Do we see there are no like terms at the top? Yes?
No, you didn't have that. Also, that one.
So if they're giving you separate terms, you need to write it as one term. So you can't, so please don't go back from this to now splitting up the fraction and going back to the, yeah, and also, yeah, so that's a good question, guys, and it has happened in the past where you're seeing, okay, here's a fraction, it's all over one term, let's split the fraction up and then simplify each term. But then you're going to end up with what was given. All right, we don't want to work in circles, guys. If they're giving you separate terms and they're asking you to simplify, you write it as one term. Okay, separate fractions. It is a bit confusing at times, but please don't work backwards. Don't put it all together as one fraction and then you want to split it up again. Okay, then we're going from reverse. All right, let's do another one. You remember doing ones like these last year, where you had variables in your denominator, but it was always one term. Yes, so but let's not get into equations now, because that's slightly different. Yes. You need to find the value for the variables. Yes. No. They might be, yes. So I'll show you. I can maybe just do one example of that. Wow, let's just push on. Okay, let me just get another one here. Okay, this is a nice one. A plus 2 over 2a minus a minus 2 over a squared. Okay, we see that we have one fraction and we are subtracting another one, so we need to find the LCD, right? Okay, basically everything that appears in the denominators, that needs, all of those things need to be a part of your LCD. So that 2, for example, needs to be in the LCD, right? Because for 2a, to divide into something, there needs to be a 2. Okay, so the LCD is going to have a 2. I suggest first looking at the numbers, figuring out maybe there are multiple numbers, all right? In this case, there was just one number, so the LCD will just have that number. But if you have multiple numbers, first figure out what the lowest common multiple of the numbers will be. Then you do the variables. How many variables do I have? How many different letters do I see there? Only one, right? A. But what is the highest exponent of A? 2. So A squared has to be in my LCD. Otherwise, that A squared is not going to divide into this. Okay. So for the first one, I need to multiply 2A by A, which means I need to multiply the top by A as well. But guys, how many terms do I have at the top? 2. So I'm going to have to multiply both of those terms by A. The entire numerator needs to be multiplied by A. So please put brackets around that numerator. If you have multiple terms, you need to put brackets around them. For the next one, the denominator is A squared. I need to times it by 2. Turn it into 2A. So I need to do the same thing at the top, but again, I have 2 terms in my numerator. So please put brackets around them so that you remember that both of those terms need to be multiplied by 2. Okay, we're fine so far. Right, let's do that. You could start multiplying it in straight away, but I'm just going to write it out like this at first. All right, so I'm just going to put that A in front. Normally, when we have something that we multiply into a bracket, we put it in the front. Okay, so like I said, you can multiply it out straight away from this top line, or you can just write that in. So guys, there's a minus in between two fractions. So that minus needs to be in the numerator, please. And what am I multiplying into this bracket? 2 times A minus 2. So in fact, I'm going to have to multiply -2 into that bracket. Okay, not just the 2. Because of that minus that's in between the two terms. And that is over 2A squared. And we do need to multiply those brackets out, because maybe if we multiply them out, we can simplify the numerator and we could possibly simplify this fraction even further. All right? So here, A times A is A squared, and A times 2 is 2A. Right? -2 times A is -2A, and -2 times -2 is +4. And that is still all over 2A squared. Can I simplify that numerator? Plus 2A minus 2A is 0, right? So I'm actually left with an A squared plus 4 over 2A squared. Am I able to simplify that further? No. So guys, if this had been 2A squared plus 4, right, then you just write that on the side. If your final answer was 2A squared plus 4 over 2A squared, right, so just add that there. It's not the final answer. I just want to show you something that you need to look out for. You need to recognize now that if you take a 2 out as a common factor in that numerator, right? Can we see that we put the pink numerator there on the side? If you take out the 2, then you'll cancel out the 2 at the bottom. Right? So in that case, you would then have to factorize and simplify, which is the types of questions that we did for homework yesterday. All right, yesterday we did a question that looked similar to this. This was the fraction simplify. You would have had to take out the 2 and then cancel the 2. All right, so if we are noticing that once we've added and subtracted, we've simplified, if we are able to then factorize and cancel something out at the bottom, we do have to do that. Okay, so from here you would have to say 2 and then A squared plus 2, right? If you divide each of those terms by 2, that's what would be left, over 2A squared. Am I allowed to cancel out now? There's one term at the top, one term at the bottom, yes. So you could then cancel out those 2's And your answer would then be a squared plus 2 over a squared. Yes,
Would it not be sort of like a minus two? Would it not be minus two a plus two? Because if you try and get that, you're times 100.
all I did, right, from here to here, look at the board, please. All I did from here to here is I just wrote that times 2 in front of this bracket instead of behind the bracket. But what sign was in front? A minus. So I didn't change anything. I haven't multiplied anything else. I just put that 2 in front of the bracket and I wrote it as one fraction. When you multiply the negative 2 in, then yes, it changes to a plus, but not before you multiply it. Okay, are you alright with this, guys? Okay, I'm just going to give you one that I want you to do on your own before we do one example on an equation with fractions. It doesn't have a nice example. Drawing my lines, I'll take the ruler right now. Here we go. I want you please to do that one on your own. Give you a few minutes. If you factorize it, is it going to allow you to cancel anything else? If not, then you don't have to. Yeah, so it's almost like you need to do the factorizing in your head and see whether it will allow you to cancel. And if it doesn't, then you can leave it as it. Or if you worry that you might lose a mark, you can factorize it. Just to be safe. just going to show you what I got. Right, so I ran out of space, so I had to write my answer here on the side. I'll just put that. So the LCD, do we agree that it was 6x squared? Okay, so the first one you have to multiply by 3x, the next one just has 2. We can see that I put that in that line. Now guys, remember there was a minus in two fractions, so you have to put a minus 2 there, and that is what the multiplying in. Now, when you simplify this, right, you actually do get a trinomial that you can factorize, okay? If I try to factorize that trinomial, you would be looking for factors of 6, and then the sum between those factors must equal -7. So this would be x minus 6, x minus 1, right? Factorize it to that. But guys, will that then allow you to cancel out anything at the bottom? No. So in that case, you don't have to actually factorize. But it's a bit of a toss-up because you kind of have to do the factorizing in order to figure out that you won't be able to cancel it out. But guys, you can also just think, if I factorize a trinomial, what do I always get? 2 brackets, right? And what do I have at the bottom? Not a bracket, a 6x squared. Okay, so whatever those 2 brackets would be, you wouldn't be able to simplify. You wouldn't be able to cancel that out. If there was an x squared or a 6, or maybe a 6x squared as a common factor at the top, then that factorizing you would have to do. Okay, so like I was saying to Daniel now, if you get into this and you're not sure, should I factorize, shouldn't I, will I be able to cancel out, will I not, rather just factorize and then leave it like that. Okay, but the risk in that is if you factorize incorrectly, I have to then minus them off. Okay, so see if you can do that kind of checking whether you do have to factorize, will you be able to cancel out? If not, you can just leave it. Okay. Guys, I want to do one example of an equation with fractions with you. Now I'm asking you very nicely, please do not get confused. When you are working with an expression with fractions, which is what we've been doing all the time so far, all right? And guys, note I didn't get to the grade 10 level fractions now, all right? So all of these types of questions, you would have to be able to do tomorrow. Okay, so we've done 3 of them now. You can look at them. There are a few more in the textbook. So I will just write down if you want to do some practice on this, maybe before tomorrow. You can look at exercise 1.24 on page 34, and then the answers are at the back of the book, so you can go check there. And it will be number 1. We have done 2 of the ones in number 1 now, but you can work through those as practice for tomorrow, okay, if you want to. All of the questions in number 1, you would have to be able to do tomorrow. Okay. So that's a nice place to just get some practice. Note, please, that all of these are expressions. Right, so when you have an expression with fractions, you need to write each fraction, each term over the LCD and put it together. Guys, notice we are not dropping the 6x squared. Right? The 6x squared is a part of your answer. You can't say that this fraction minus this fraction is just x squared minus 7x plus 6. Okay, that denominator is still a part of the answer. You have to keep it there. Okay, so maybe just add here. What we practice now, all of these were expressions. It's very important. I was actually planning on not even doing an example with you guys because I don't want you to get confused. But please, this is what we do when there's an expression. So when there's no equal to 0 or equal to 3 or equal to another fraction. Okay? I'm going to do one example quickly of what we can do when we have an equation with fractions. Okay, this is a completely different chapter. Okay, we're also going to get back to this chapter. I'm just going to do an example quickly to help you get ready for tomorrow. Because tomorrow you need to be able to do grade 9 level fractions. Okay, so the one that I'm going to do now, the grade 9 level equation, sorry, the one that I'm going to do now is a grade 9 level 1. I'm just going to write here equations with fractions. And I'm going to go quite fast. We only have about 10 minutes. That it should be enough time. Mhm. Here's your practice. Okay. Just hang on, give me 1 second. Right, I am going to do this one with you guys. So the question says solve for y. Right, it can obviously be any variable, it depends on how big it is in the question. So we have 10y minus 1 is at the top of the first fraction, that is over 2, equals 4 bracket 7y plus 1, close bracket, that is over 5 minus 1. And we need to solve for y. I'm noticing that there is now an equals, it's no longer an expression, it is an equation. And they are asking us also not to simplify, they're saying solve for y. So we need to find a value of y, that makes this equation true. So if I have a value for y and I put that value there, I actually calculate this number, then it should be equal to what I get when I put the y value here and calculate this number. All right, so we are finding a value for y. Yes? Yes. All right, so guys, the easiest way, and you should have learned this last year, is to multiply by the LCD. All right? To multiply everything in this whole equation by the LCD, so every single term, even the terms that are not fractions. All right, every single term you're going to multiply by the LCD. And that's the reason why we do that, is because we're trying to get rid of the fraction. Okay, most people don't like working with fractions. So the first thing that we actually want to do here is we want to get rid of those denominators. So if I multiply the first fraction by a number that 2 can divide into, I can do that division and the 2 will go away. If I multiply this one by a number that 5 will divide into, I can actually divide, I can cancel out the 5, and I won't have a fraction anymore. But guys, the bottom line here is that this is an equation. Whatever I do on the one side of the equation, I have to do on the other side. Since there are multiple terms on this side, I need to multiply both of those terms by the LCD. All right, so we are going to multiply every term by the LCD. Notice that this is different from what we did in the previous one. In the previous one, we wrote it over the LCD. All right, when you're solving an equation, we're going to times by the LCD. Now, what is the LCD of 2 and 5? 10. I'm going to multiply this by 10. I'm going to multiply this by 10 and the negative 1 as well. Every single term. Okay? Every term is being multiplied by 10. Now we need to remember again, we have 2 terms here at the top that are multiplying by 10. So let's put brackets around it. Here I need to remember that there is already a 4 there, right? So this is actually a 40 in the sense. Okay, we'll talk about that now. Okay, and guys, please put that times 10 there at the top. It makes it a bit easier. About 10 is the same as 10 over 1. Is that correct? So actually you're multiplying the top by 10 and the bottom by 1. Okay, that's often a question that I get asked. Ma'am, why are you only multiplying the top by 10? Because when you multiply a fraction by 10 over 1, you're multiplying the numerator by 10 and the denominator by 1. Okay, so we are just multiplying the top by 10. Now what's happening here? What is 10 divided by 2? 5. That 2 is dropping away. Okay, we're canceling the 2 out essentially by saying 10 divided by 2 is 5. What is 10 divided by 5? 2. So I'm ignoring that 4 for now. Okay, I'm just looking at the 10. 10 divided by 5 is 2. Okay, so what am I left with here? I have a 5 and 10y minus 1. And what is left at the bottom, guys? If I cancel out that 2 and then put this to 1, do I need to write that over that? No. You see what we've done now? By multiplying this fraction by something that 2 can divide into, we've actually been able to cancel out that 2, that denominator. That is equal to, now we need to be careful because there's a 4 and there's a 2. So what am I going to do with these? What do you guys think? Multiply them. Hey, so it's going to be an 8 in front of this bracket, 7y plus 1. At the bottom, I'm left with 1 because I said 10 divided by 5 is 2. And there was the 1 there, so I don't have to write that. Minus, what's 1 times 10? 10. Now this is an easy equation to solve, right? We know fractions. So that is what you do every time you have an equation involved in the unextraction equation with fractions. You multiply every single term by the LCD. And if you do this in an expression, you get 0 straight away. Okay, so you need to make sure when you're getting ready for tomorrow's class that you are clear on the difference between what you do with an expression with fractions, you write it over the LCD, and an equation with fractions, you multiply by the LCD. Okay, please don't get those two mixed up. Okay, let's quickly solve for y here. 5 times 10y is 50y. 5 times negative 1 is negative 5. Right? What is 8 times 7y? 56y. 8 times 1 is 8, and then minus 10. Okay, when we have an equation with brackets, we need to first just multiply all those brackets out. Then we need to put all the y's on the one side, right? So we have 50y here. This 56y, when I move it, it's going to become negative 56y. What's 50 minus 56? Negative 6. Okay, so that's negative 6y. Sorry, I'm going quite fast without finding each other out. Here we have an 8 minus 10. What's that? Negative 2. And then this is going to come out plus 5. All right? So what's negative 2 plus 5? 3. Now, to get y on its own, I need to divide by negative 6. So what is 3 divided by negative 6? Negative a half. You can write negative 3 over 6, but then you have to write negative a half. Okay, you have to simplify. So I need to be able to do this for tomorrow as well. Okay, I'm going to type up that little thing now when I post the video link to today. So the list of everything that you need to know for tomorrow will be there.